Hello my dear students, welcome back to NEET World. So in this session, we will be discussing 2 marks question for your class 12th IPE chemistry. Okay, and this is from Haloalkanes, Haloarenes as well as we can also discuss from other organic part also, from amines as well as aldehydes, ketones, carboxylic acids. Okay, so just follow this session till the end so that we will get some clarity on this chapter. Okay, yeah, so from this discussion itself we can expect a 2 marks question. Okay, and once after completing these questions, if you have time you can just go through the other questions also. Okay, but you first need to cover this because these are the most repeated questions in your class 12th IPE exam. Okay, second year IPE exam. Okay, it will be useful for both Telangana and AP students. Okay, right. So the first question here says what are enantiomers? From this haloalkanes and haloarenes we have first question is what are enantiomers? See, enantiomers are stereoisomers that are related to each other as non-superimposable mirror images. It means I will tell you with a very simple example so that you will feel more clear. See, what do we mean by enantiomers? See, once again, the enantiomers are stereoisomers, means enantiomers are stereoisomers that are related to each other as non-superimposable mirror images. It means if this is an organic compound, okay, this is a compound now, like my right hand is a organic compound now. Now what I am doing is I am placing a mirror here. Just imagine there is a mirror here. Okay, so in the mirror you will be seeing the image of this right hand like this as my left hand right now. So these are the two mirror images now. This is one real image and its mirror image is here because in between we have a mirror. So now you just take your right hand and you keep it on its mirror image like on the left hand. What you are going to see? Yeah, you are going to see something like this. See, are they superimposing? It means see, here we have a little finger, but this hand you have a thumb finger. So are they same? No, right? So if it is something like this, little like mirror, little finger, thumb, like that, it means you should say it as superimposable. But here if you are observe, it is something different. See, here index, here little finger, something like different fingers are there now. So these are non-superimposable mirror images. They are not merging, right? So these are not superimposable mirror images. These are non-superimposable mirror images. Okay, I hope you got some clarity. Now in the same way, when you consider organic compounds, let us say what I am taking here, I am taking a carbon with 4 different groups. Let us say this is A, B, something like D, and here E. These are the 4 different groups I am taking. Now just take its mirror image. So if this is a mirror, so what you are going to get, its mirror image something like this. See, here D is there, here D you will get, here B, and here you have A, here you have A. So E here. So now this is a tetrahedral geometry. Now you bring this carbon like this compound and place it on its mirror. So will they on its mirror image, will they superimpose, will they merge? No, right? So these are called non-superimposable mirror images. So now this compound A and this B are now 1 and 2 are called enantiomers. See, enantiomers are stereoisomers. What do we mean by stereoisomers? Stereoisomers are isomers which have differ in their spatial arrangement. For example, if you see, let us say this B is above the plane molecule, above the plane compound. Okay, like atom here or group. Okay, and let us say A is below the plane. Okay, now when it comes to its mirror image, A becomes above the plane. Okay, B becomes below the plane. So it means what you got to know, these are stereoisomers. What do we mean by stereoisomers? Isomers which are differ in their spatial arrangement. See, in the 3-dimensional space, B is above the plane, but here B is below the plane. Here A is below the plane, here A is above the plane. So this small difference is there now, above the plane, here below the plane. Bond connectivity, everything is same, but they differ in their spatial, in the 3-dimensional spatial arrangement. So you should call them as stereoisomers. Now read again. Enantiomers are stereoisomers which are related to each other as non-superimposable mirror images. See, they just differ in the spatial arrangement of atoms. One is below the plane, here above the plane. Okay, like that now. So this spatial arrangement differ is there now in these 2 molecules. Now one molecule will not superimpose on other. right now. So they should be called as enantiomers. Okay, I hope you got the clarity what is mean by enantiomers. If it is clear, just hit on the like button so that I will confirm you are following the class very clearly. Okay, then next, they are optically active compounds. Enantiomers are optically active compounds, meaning they rotate plane polarized light by an equal amount. They rotate plane polarized light equal amount. If this is rotating plane polarized light right side with some angle, with the same angle, this its mirror image will rotate left side, okay, in opposite direction. See, they are optically active compounds. Optical active compounds means what? They have ability to rotate something called plane polarized light. They have ability to rotate plane polarized light. If its real image is rotating right side, then its mirror image rotates left side, like that. So they are optically active compound, meaning they rotate plane polarized light by an equal amount but in opposite direction. It is right, that is left, okay. So one enantiomer is designated as dextrorotatory and other enantiomer is designated as a levorotatory, okay. If this is dextro, its mirror image will be levo, or if it is levo, its mirror image will be dextro. Like that, you need to understand about these enantiomers. Hope the discussion is clear. Right, let's move for the next question here. The second question is, what are ambident nucleophiles? Okay, so what are ambident nucleophile? See, what do we mean by ambidextrous? See, there are some people who can able to write with left hand as well as right hand right now. So those are ambidextrous we are saying. So here if you observe, what are ambident nucleophiles? Okay, that is N. What are ambident nucleophiles? I will tell you in a simple way. See, this is ambident nucleophiles. Okay, right. So first of all, one more thing I just wanted to add here before moving to the question. Now you can access this material. See, this is our NEET World material designed for your IPE exams. Okay, it is available for physics, chemistry, mathematics for MPC, biology, physics, chemistry for BPC students. Okay, now you can access this for free of cost from our NEET World app. Just go to Play Store, download NEET World app. Okay, and by using your mobile number, just log in. Then you mention your class in first year or second year along with your group. Then our team will guide you how to access this material for free of cost from that app itself. Okay, now you can download them and you can just go through these pages. If you open the book material, after downloading you are going to see these lines. Okay, just to go through them, so you will feel more confident by listening to the class after reading it once again right now. Yeah, so I hope you got what I am saying here. The next, the question says, what are ambident nucleophiles? See, ambident nucleophiles are chemical species that possess two or more different nucleophilic centers. Okay, it means, see here, I am writing one best example is cyanide, Cn minus. Okay, so on nitrogen we have negative charge, on carbon also we have lone pair electrons. Okay, so now it is an electron rich species. I can say it is a nucleophile. So it has ability to make a bond or donate the electrons either from carbon side or from nitrogen side, but not from both sides. Here I am saying from either carbon side or from this nitrogen side right now. So it can have ability to rotate, make a bond from right hand side or from left hand, like that. Okay, and ambident nucleophiles are chemical species that possess two or more different nucleophilic centers, atoms with high electron density like this, through which they can attack an electrophilic site. So this allows them to form two different structural isomers depending upon which atom is attached to the substrate. For example, let us say there is a substrate here. Okay, there is some electrophile here. Electrophiles means electron deficient. Now this cyanide can make a bond using this carbon side. So you are going to get something like ECN. Okay, this is one possible way, and it can also make bond from this nitrogen side. So ENC. Okay, so this is second compound. See, both of them have same molecular formula, but bond connectivity is different. This is from carbon, this is from nitrogen right now. So these are now isomers, structural isomers, right? So this is what happens when a ambidentate nucleophile is involved. So what are ambidentate nucleophiles? Those are ambidentate nucleophiles are chemical species that possess two or more different nucleophilic sites that will be attack on the electrophilic center. Okay, those are considered to be ambident nucleophiles. Okay, give this kind of example, or one more example I am writing here. See, NO2 minus, okay, O minus, NO, lone pair. See, now nitrogen can make a bond with the electrophile, or this O minus can also make a bond with electrophile. So there are two sites. Using any of the site, the molecule, this nucleophile can attack on the electrophile. Okay, so this kind of ligands are called, or nucleophiles are called ambidentate nucleophiles. Okay, hope the discussion is clear. Let's move forward. Right. So here you can see cyanide is an example they have given, and nitrate ion also they have given. I clearly explained about them. Right. Let's move forward to the other question. The question says define racemic mixture. What exactly racemic mixture means? See, the first question we have discussed is about enantiomers, right? So we discussed that there are two mirror images. If this is rotating right side and this rotate left side like that, we have discussed about enantiomers. Now, if we have equimolar mixture of this R isomer and S isomer, dextro isomer, levo isomer, then the resultant mixture is called racemic mixture. So now read the statement. The racemic mixture is a combination of equal molar amounts of pair of enantiomers. If two enantiomers are of equal amount in the mixture, then that mixture is considered to be racemic mixture. Okay, and racemic mixture is optically inactive, because we know if dextro molecule rotating right side, then this levo will rotate left side. Okay, since they are equal amount, then net rotation becomes 0, because each like both of them are cancel out each other, net rotation becomes 0. So that's why it is optically inactive. See, racemic mixture is a correction of equal molar amounts of pair of enantiomers, that is dextro and levo. Since the opposite enantiomers cancel out each other, racemic mixture is optically inactive. Okay, so this whatever the cancelling out each other is there, optical rotation cancels out each other, so that is called external compensation. Okay, now it is indicated with the prefix like D and L or plus minus. So this plus minus means one is rotating plus direction, other one rotating minus direction, cancel out each other. So that's why we are indicating racemic mixture with plus minus. Okay, so racemic mixture, butane 2-ol. So at second carbon we have I'll write the structure so that you will feel more clear. This is butane. So at second carbon, let us say this is the second carbon, I can place OH group above the plane, or I can place OH group below the plane like this. So R number will be S. If it is S, it will be R. If it is dextrorotatory, levorotatory. Okay, if I have equal amount of mixture like D and L isomer of equal amount, now what happens? That net rotation, optical rotation will be 0. Okay, that's it. So you can represent this example. DL, if it is plus, it is minus, or if it is minus, it should be plus. So the combination of these two with equal amounts give you racemic mixture. That's it. Okay, right. So this is about racemic mixture. The next question is about explain Woods-Fittig reaction. So what is Woods-Fittig reaction? You know guys, this is one of the favorite topic for your EAP set exam also. Like examiner will focus on what are Woods reaction or Fittig reaction, this kind of question from hydrocarbons. Anyways, we'll learn it here. Okay, I will tell you the simple way. Just follow me. When they say Woods reaction, you need to take alkyl halides. What you need to take? Alkyl halide. And you need to treat this with sodium metal. Okay, with sodium metal. So let us say if you are taking 2 moles of this alkyl halide. So this is one alkyl halide. Okay, and similarly one more alkyl halide you are taking. Okay, like this you are taking now. So you just remove this halides. So what is the remaining part? RR now. So that's it. This kind of product is formed. If you are taking methyl chloride, you are going to methyl chloride. You just remove that chlorides, methyl. You are going to get ethane as your product. Okay, like this you need to make your product formation. Okay, now read this once. The Woods-Fittig reaction is a coupling reaction used to prepare alkyl arenes, that is alkyl benzene. See, here I explained about Wood's reaction. When it comes to Fittig reaction, similar to alkyl groups, there is involvement of only aryl groups, like aryl halides are taken. Okay, so again remove this halides, just combine those two aryl groups. Okay, you are going to get something like this. Okay, like this. So this is called Fittig reaction. Now it's a combination of Woods and Fittig. It means you should take 1 mole alkyl halide, the other mole aryl halide. Okay, it means one is aryl halide, other one is alkyl halide. We need to consider. Okay, now let's consider one alkyl halide plus one aryl halide. Okay, so now what I am saying, you just remove these X groups. Okay, so that you are going to get R like this. Okay, benzene with alkyl group, alkyl benzenes are formed. Okay, so reaction, an aryl halide like chlorobenzene, like chlorobenzene, bromobenzene you can take, react with alkyl halide like ethyl halide, methyl halide, like that you can consider. Okay, so in presence of metallic sodium, so what we need to consider, sodium metal in dry ether condition you should take. Okay, sodium metal in dry ether as solvent. Okay, so that gives you alkyl benzenes. If I take methyl chloride and chloro for one, you are going to get methyl benzene. Okay, right, that's it. Toluene will be prepared in that way. Okay, so if you are taking ethyl chloride and chlorobenzene, you are going to get ethyl benzene. Like that we can make alkyl benzenes from the Woods-Fittig reaction. I hope you got some clarity on this Woods-Fittig reaction. Important thing is sodium metal to be mentioned and dry ether condition also should be mentioned. You should not take a wet condition, you should maintain only dry ether. Okay, right. Then next, how is Grignard reagent is prepared? Yes, this is also easy and important. So Grignard reagent is prepared from alkyl halides upon treating with magnesium. So first of all, what do we mean by Grignard reagent? So Grignard reagent means you should remember the formula as RMgX. Okay, means alkyl group, magnesium and a halide should be there. Okay, so for example you are taking methyl chloride like that, alkyl halide you are taking and you are treating this with magnesium metal. Okay, we know magnesium is a alkaline earth metal, it will be donating 2 electrons, right? Now Mg plus 2 it will exist in the compound. So a Grignard reagent which has a general formula as RMgX, okay, is prepared by treating alkyl or aryl halides with magnesium metal. Okay, and it should be must be carried out in presence of dry ether. So you should mention here dry ether, there should not be any wet condition. Okay, if wet condition is there, so magnesium react with that water, whatever water wet condition is there. So that's why it should be mentioned as a dry ether. Okay, now what is going to happen? This magnesium will insert between this R and X. So you are going to get RMgX. That's it. Okay, this is called Grignard reagent. This is one of the very useful reagent in synthetic organic chemistry reactions. It means we can prepare lot of organic compounds or organic synthetic materials from this. It's useful in organic synthesis. Okay, remember. So this is what we made till now. Okay, the next question from here is, write the possible chain isomers of the compound having molecular formula C4H9Br. Okay, so yeah, C4H9. So what is the formula? It is C4H9Br means it is accepting like what type of formula. First of all, identify whether it is an alkene or alkyne. Okay, see, we know the general formula of alkanes as CnH2n plus 2 right now. So it can be hydrogen or any monovalent atom. So here you have a formula something like C4H10, right? Yeah. So now try to substitute here C4H2n. So 2 4 is 8 plus 2, so 10. So it's an alkane now. It is satisfying this formula means the given compound is an alkane, right? Yeah. So once after knowing that is an alkane, you can write 4 carbons means it's a butane. So butane like this, and one position must have bromine. So you can write here 1 bromobutane, right? Like this we can make the structures. The molecular formula of C4H9Br has 4 possible structures. Okay, let's see what are the 4 possible chain isomers. See, I can place bromine at the first position, or I can place bromine at the second position like this. Okay, see, 1 bromobutane, this is fine. Then next 2 bromobutane, this is also done. Okay, then next is there any other possible way? If I keep here, that is also 2 bromobutane only, so no point of writing in that way. So I am writing with 3 carbons. Okay, here methyl group, here bromine. Okay, and the next one here, see, 1 bromo, 2 methyl propane, yes, this is done. Then next 2 bromo, 2 methyl propane, yes, this is done. Is there any other possible way? No, right? So these are the only 1, 2, 3, 4 possible ways to write structural isomer, that is chain and positional isomers for the given formula, because they are asking possible chain isomers of the compound. Yes, what are the chain isomers? It means they should differ in the chain. So they differ in the chain means here it's a 4-member chain. Okay, so this is a 3-membered chain, like this is a 3-membered chain. Like this you can represent 4 isomers. Okay, right, let's move forward. Next, yeah, so now we are going to do the questions from amines chapter. From amines, that is organic compounds having nitrogen. Okay, let's do this. Now let me take some water. Yeah, so here the question says write the equation for carbyl amine reaction of any one aliphatic amine. So you can take any aliphatic amine and treat that with give the carbyl amine test. See, what do we mean by carbyl amine test? First of all, see, carbyl amine test is a test used to identify primary amines. What amines? Primary amines. Okay, so now primary amine, upon treating with chloroform in basic medium like KOH or NaOH, we are going to get a foul smell, very bad smell, by the formation of alkyl isocyanates. Okay, now I will tell you the example. So it is given only by primary amines. Remember this important statement. This is given by only primary amines. You remember carbyl amines. So you just take RNH2. So on nitrogen only one alkyl group should present. Okay, so NH2 should be there and R group, like that. So primary amines, upon treating with chloroform CHCl3. Okay, so in basic medium like 3KOH you can say. Yeah, so under heating condition what happens is this nitrogens and these chlorines are removed. You are going to get RNC. Okay, this is the carbyl amine product form. Okay, so this is called alkyl isocyanates. Okay, what is the product called? Alkyl isocyanates. Okay, since it's a primary amine, we are getting that kind of product. It is given only by primary amines. Remember this, it will be useful for your JEE, NEET and EAP set exams. See, now what they are asking, the carbyl amines or isocyanate test is used for test for amines, primary amines. Okay, reactant, it should be a primary amine, and chloroform and a base like potassium hydroxide is used. Okay, KOH. The product formed here, the reaction yields alkyl or aryl isocyanates, which has an extremely foul or unpleasant smell. So it will be having very bad smell, foul smell you can write. Okay, yeah. So this is what the equation you can mention. Okay, this is what the final equation you can mention. Okay, so primary amine plus chloroform plus 3 KOH, upon heating you are going to get alkyl isocyanate plus 3 KOH we have taken now. So 3 KCl it will form and 3 H2O. You get. Yeah. So the next question here, arrange the following in the decreasing order of the basic strength. Okay, so they have given 3 amines, they are asking us to arrange them basic strength order. It is also important and easy. Okay, like I will tell you. Write their structures first. Ethyl amine, first one is, so this is simple, ethyl amine is there. Okay, and second one is phenyl, like benzyl amine is there, like aniline it is. Okay, and next one is ammonia we have, and the last one is benzylic amine, like CH2 NH2, like this we have. Okay, write their structures, it is easy. Then see what they are saying, basic nature of amines is determined by electron density groups. If there are electron releasing groups, basic nature of amines is more. If there is anything like electron withdrawing group, they will withdraw the electrons, these lone pair electrons towards themselves, and their basic nature decreases. Okay, right. So now here electron withdrawing groups like aryl group also here consider, decreases the electron density due to the resonance and making the amine much weaker. Okay, so now these lone pairs of this aryl group, I mean nitrogen, will involve in the conjugation, so it makes it to be very least basic. Because what do we mean by basic nature? That lone pair should be donated to the H plus ion. If that lone pair electrons are freely sitting on the nitrogen, they can be easily donated. But here they are in conjugation now, so they are very less available due to the conjugation of lone pairs. So it is the least basic. So who is the least basic here? So this one will be a least basic. Okay, so like aniline is least basic, after that ammonia. Okay, right. So you can see here they have mentioned benzyl amine, that this one is attached to an alkyl group, so it is, so there is no resonance here as we seen in the aniline case. So which is the least basic? I told you aniline. So why aniline is least basic? Because I told you that it involves in the conjugation. It involves in the conjugation, like lone pair electrons of nitrogen are in conjugation. So due to that reason it is least basic. After that ammonia. And why these are more basic? Ethylamine is, why ethylamine is more basic? Because here alkyl group is there now, there is no such conjugation as we seen in aniline. So it will be only donating the electrons, like electron releasing group. So this lone pairs easily accepts the H plus. If there is more electron density on the nitrogen atom, it will easily donate it to the H plus. Okay, that's why ethylamine is more basic. After that benzyl amine, next ammonia, and least is aniline. That's it. Okay, the next, look at this, give the structure of A and B. See, it's very easy what they are doing. So they are hydrolyzing phenyl cyanides, like cyanobenzene I can say. Okay, so it is like this. So when you do acid hydrolysis here, so when we are doing acid hydrolysis, upon partial hydrolysis we are going to get amides, but here on complete hydrolysis we are going to get a carboxylic acid. Okay, you are going to get this kind of product. So this is our A. So A treated with ammonia. With what? Ammonia they are treating. So they are treating it with ammonia. Now what happens? This NH3 will attack here and H2O goes out. You are going to get amide as your product. Okay, like this. These are the products formed. So now you can read this. The reaction sequence involves hydrolysis of nitrile followed by acid base reaction. See, cyanides like cyanobenzene undergoes acidic hydrolysis to form a carboxylic acid. Yes, benzoic acid is a product. Okay, and the next structure A is benzoic acid. Next reaction 2, that is A with ammonia. So benzoic acid react with base ammonia to form ammonium salt first. Okay, yeah. So see, it will be, see, this is acid, this is a base now. So we can also expect here, we can also expect like O minus NH3 plus NH4 plus. This is a salt. Okay, but if they are asking us to heat also, so we can expect elimination of water and gives you amide as a product. What is the product if we heat this? Yeah, this is the final product. Amide is a final product upon heating. But if they are not mentioned any heating condition, you just leave it up to this salt formation, ammonium salt formation. That's it. Okay, so as per the question mentioned, there is no heating condition, so you just mention up to ammonium benzoate, up to formation of the salt. That's it. Okay, right. Let's move forward with the next question. So next one is, write the IUPAC names of the following compounds, classify them into primary, secondary, tertiary amines. Again it is easy, I will tell you the tricky way. Okay,
membrane most
first write the structure of this. See, you know ammonia, right? Just follow this ammonia. Na? So from this ammonia, you replace one hydrogen with one alkyl group, so that you are going to get RNH2. Okay, if you replace two hydrogens with alkyl groups, NRH, right? If you replace all three, you are going to get R like this. Okay, so if one alkyl group is present on nitrogen, like NH2 type is there, it should be called as a primary. If two alkyl groups are nitrogen, secondary. If three alkyl groups, tertiary. That's it. Okay, now write their structure. See, we have NH2 group, it means definitely it's a primary amine. Okay, now write the structure. CH is there, NH2, CH3, CH3. So 1, 2, 3. So second position amine group is there. So propane 1, 2, 3 na. So propane 2 amine. See, it's like NH2. So you should say it
chloroplast and mitochondria.
Okay. So the next one here, if you see the second structure, that is a CH3, CH2, CH2, NH2. Yes. Here it is also a primary amine having 1, 2, like 1, 2, 3. So propane amine, like propane first position amine is it. So propane amine, so it is also primary amine. Next one here, if you observe this, you are going to get a secondary or tertiary. Let us see once. Yeah, it's a tertiary. Now write the structure like CH3, CH2, N, 2 times are there now. You can write CH2, CH3 one more time, and one more CH3 is there, right? So like this we have. So how many alkyl groups attached to the nitrogen? 3. So it should be a tertiary amine. Okay, that's it. In the next, writing its IUPAC name, how can you write is, identify the longest chain. See, 1, 2, this is the longest chain. Here also 2, this is 1. So now longest chain is considered to be ethyl, right? So that should be, the name of that compound should end with this ethane amine, and one, what are the groups attached? Methyl group and one more ethyl groups. So you should write N-ethyl, alphabetical order here. N-ethyl, N-methyl, ethanamine. So N-ethyl, N-methyl, ethanamine is the name of this compound. That's it. Okay, 3 carbons are attached to the nitrogens, like 3 alkyl groups. So it should be called as a tertiary amine. That's it. Okay, so I hope you got how do you write the structures and IUPAC naming and classification of amines, right? Yeah, let's move forward. Yeah, this is the last question of this discussion. Arrange the following in the decreasing order of their basic strength. See, they have given aniline and they have given aniline. Yeah, they have given aniline and ethylamine and diethylamine and ammonia. Yes. So how can you do this? Just now we have seen similar type of question. Writing these structures, if there is any conjugation or electron withdrawing group, it will be least basic. Now see here, this is second structure is aniline. So it means it should be least basic. Why it should be least basic? The lone pair electrons are in conjugation here, So it is the least basic amine. So aromatic amines are least basic or less basic than aliphatic amines, you can remember. Now here you have one ethyl group, here 2 ethyl groups. So more the electron releasing groups, more is the basic nature. So secondary ethyl amine, amine here, diethylamine, N and diethylamine is more basic. It means 1, 2, 3, 4, 5, right? So 3 is more basic. After that 1, okay, and the next ammonia, normal ammonia, and least is 2. Okay, least is 2. That's it. This is how you need to write. Okay, so now read the statements, whatever mentioned in the notes here, it will be useful to present in the final exam. See what they are saying, diethylamine strongest base in the given compounds, the 2 ethyl groups provides electron density, like by plus m effect, it releases electrons, plus I effect is there. So due to that, it will be donating lone pairs easily to the proton, so it is more basic. After that, ethylamine, and after that ammonia, and least is aniline. So this is what you need to mention in the exam for 2 marks question. Okay, you can directly write the order, but it's good if you provide the little explanation at least. Okay, right. So hope the discussion is clear. And Mukesh in the comment box asking, hello sir, hello dear. So is this clear whatever we have discussed till now? Yeah, if the discussion is clear, please hit on the like button, and if you have any queries, feel free to ask me. Okay, right. So here all the 2 marks questions are over from haloalkenes and haloarenes as well as amines chapter. Okay, the remaining things will be discussed in the upcoming sessions. Okay, in the next session. Okay, in the next session I am going to cover the 4 marks question. Few chapters are left. Okay, if we complete that, yes, most of the topics are over. Okay, right. So you just stay connected with our NEET World YouTube channel, and you can share with your friends who are preparing for IPE exams. Okay, as well as we are doing for EAP set, JEE, NEET exams also. Every day I will be taking one live session for NEET, EAP set and JEE exams. You can join them. Okay, today we will be having a PYQ session for amines as well as other organic chemistry part from JEE, NEET and EAP set exams. You can join it. Okay, so thanks for watching. Stay connected. Thank you for watching.